So on 1.8, so what you just turned in was the top one, and you took a do now on it. Now it's the second half. So again, inverses. Inverses, the first thing I think about is switching x's and y's. Maybe another way of thinking about it is my line of reflection is y equals x. Again, x equals y equals x. We talked about that. Let's see, I don't want that piece. Let's see, we went through the formal definition. In the formal definition, we did something new with the composites that we learned in 1.7, which we didn't do in Algebra 2. So in the composites, a composite means I put one function inside of another. So if I have two functions and I want to see if they're inverses each other, in other words, every point on the first graph, if I switch their ordered pairs on the second graph, I have this like test, or I use this definition. So I substitute in for the variable for f, g of x. So when I do f of g of x, if I get x, and I must do it the other way around. If I also get x, then yes, these two happen to be inverses. Then what I usually do is I'll take that second one and I'll rename him as f inverse. So that these two go together. This is the original, this is its inverse. If there's a point 1, 2 that lives on this, then it lives here at 2, 1. The other thing we learned in this definition is, which makes sense to us, is the domain and ranges. So the domain and range of the original function, they switch. The domain of the function becomes the range of the inverse function. The range of the original function becomes the domain of the inverses, because those x's become y's and those y's become x's. All that means. All that means. So what we did is we first verified inverses. We were given to verify or confirm that they really are inverses. Well, that means I used that definition, right? That's what I did. So you had to do it both ways. If you got an x both ways, then yes, they are inverses. If you got an x and a negative x, and x a 2x, x and anything else, then they're not inverses. They're not. In other words, they're not a nice reflection over the line y equals x. Let's see, what else did we do? Oh, we did do this last year, and we found the inverse of a function, and we worked through these 4 steps, which is what we just did before your do now. You take your f of x, replace it with y, then switch out your x's and y's, and now solve for y. I mean, right here is where you do the forced inverse. You switch it out. Then when you're done, you replace that y with f inverse of x. So we did that. We did a really hard one today. We did this one, and then 3, which is where I kind of ended. This thing called the horizontal line test. Horizontal line test. So I had this graph, and if I put a horizontal line through it, and if I intersect that graph twice, then when I take the inverse, I can still take the inverse of it, but it's not a function now. This is a function because it passes my vertical line test. When I take the inverse of it, it's still going to be a function. How do I know that? Because it passes my horizontal line test. This guy here, he's a function. My parabola is upside down. And I can take the inverse of him. That's not an issue. The problem is when I take the inverse, it's no longer a function. So I'm going to say it fails the horizontal line test. It fails it because the inverse is not a function. Not because I can't find an inverse, because its inverse is not also a function. So that's what this tells me. Not whether or not it has an inverse, it tells me whether or not that inverse is also a function. How do I know if it's a function? It passes the vertical line test now. Right? So now where I'm going to continue, which a lot of this is review. In fact, this is all review here. Graphs of f and f inverse. Oh, you mean these two, when I graph them, are mere reflections of each other over the line y equals x? Yeah. Oh. So this is how I could write one ordered pair. I don't have to write it like this. On the f function, if the x is 3 and the y is 5, then on the f inverse, that becomes the x and that becomes the y. It's easy to see in ordered pair notation. Do you understand what it looks like in function notation? So they're actually going to have you do just a couple of math problems where they're going to give you a function already graphed out. Just one. It's going to be f. And they're going to ask you to draw an f inverse. What do? Just switch the points, sketch it in, right? And so, you know, if it looks like this, what points? I usually pick these kind of points, right? I just find their ordered pairs, then I switch those ordered pairs, and then I just sketch the segments in between. I don't necessarily find this point or this point. We find the end points of all the segments. So I would find 4 points, where they are, what are they graphed to be, then I switch them, I graph those in. Done. Done. There's some other homework. Let me make sure it's not on the next page. Yes. There's some other homework. Let's see. What am I giving you? What is the homework again? So don't do one of your homework problems. 39 through 37 odd. So let's try 40. So the first thing you're supposed to do is find f inverse. It just says find f inverse of x. It says this. Find f inverse of x. How do you want me to do that? Correct. I don't go and try to sketch that graph. I might as well just do the algebra way of finding an inverse. Let's see. I'm going to make that a y. I'm going to switch it. Isolate the y. X plus 3 equals 2y. Then divide by 2. So that's x plus 3 over 2, which could be rewritten as 1/2 times x plus 3, which could be rewritten as x over 2 plus 3/2. I mean, I don't know. Just figure out what the back of the book. Maybe it has it here, maybe it has it here, maybe it has it here. Are they all correct? They're all correct. They're all correct. Okay, so I found part A. B. It says graph f and f inverse. Tell me how you might do that. So it wants me to graph this guy, and I don't know, pick your choice of whichever one that is. Wants me to graph those two. What would your plan of attack be? First off, you're going to get graph paper, because I want all graphs on pretty graph paper, not line paper. What would you want to graph first? Yeah, the f of x equals 2x minus 3. Isn't that just a nice, simple linear function? How do you graph linear functions? Let's go ahead and let's review. In fact, I'll do it here. That's right, I'm recording. Right, y equals mx plus b. How do you graph these quickly? No t-table. You should be able to do this quickly. No t-table. What do you graph first? Graph the what? The y-intercept. What is the y-intercept? -3, right? Isn't that your b? That's where the graph intersects the y-axis. So somewhere at 1, 2, 3, -3. There it is. Now what do I do with that 1 point? Do slope to it. What's my slope? 2 over 1. 2 over 1. Done. Got 2 points. Sketch it in with a straight ruler, right? Because we are honors pre-calculus. We're not algebra 1. Right? So we do everything nice and neat and anal, right? Okay. Unlike me. That was sad. All right. So it said graph. Okay, I did that. Now how do you want me to do this guy? Which one of these do you want to go graph? Yes, please. Please share.
The graph itself?
Oh, the graph itself? You don't want me to look at one of these? You want me to look over here? Why?
Because it's like easier just to look at it.
Easier. Oh my God, don't do this. Yuck, yuck, and double yuck. Right? Oh, I want to go find the y intercept of 3/2. I don't mind the slope being up 1 and over 2, but yuck. Right? I'm anal. I want it perfect. Why not just take these ordered pairs, find out what they are, and switch them? Done. Mathematicians are lazy. We find the simplest, fastest, most accurate way. I'm going to screw up if I try to find 1.5 and go up 1 and over 2. You're not going to jack it up. You're not. That's a nice ordered pair. That is 0, -3, and that is 1, -1. I can switch that. Get the new one. Right? Done. So I've done part B. You might not understand what I just said. Are you okay? Okay. Right. So Right, isn't that one order pair? Isn't that the one? Whoom, done. Right, switch, done. So you're going to tell me on the graph, hey, this one's F. Then when you sketch that one in, you're going to tell me at the end of it it's F inverse. Because you're anal honors math analysis students, you want to make sure I give you all the points and that I clearly understand what you do. Let's see what C says. It says use interval notation to give the domain and range of F and F inverse. Now this one happens to be an easy one. So I'm supposed to find the domain of F and the range of F and the domain of F inverse and the range of F inverse. Well, let's just do this one here that I've already got graphed. Can't I use all x's in the, what was this? Oh, here it is, right there. I can use any x I want. What y will come out of it? Any y, all y's. This one happens to be an easy one. Just for a minute, let's pretend it isn't, just so that we can understand how to do this. Let's pretend this was 2. Just going to change one little thing. If you could answer this one again. How would I do the domain and range of the F inverse?
Switching.
Oh, that goes there and that goes there? Okay. Right. The x's become the y's and the y's become the x's? Oh, okay. Isn't that legal? Isn't that what my definition said I could do? Did. The definition of inverses said I could do that. Oh, yeah, right there. That is equal to that, and that is equal to that. So the domain becomes the range, and the range becomes the domain. Any questions? We briefly touched on this last year. Find the inverse of a domain. I'm sorry, a domain restricted function. I ran out of room. It's a domain restricted function. I'm going to take my domain or my x values and I must restrict it. What is that about? I'll let you write that and I'll show you exactly what that's about. Maybe you'll remember from last year. I don't know. There's my parent function of my parabola, my 5 key points. 0, 0, over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4. Does this pass my horizontal line test? No. That means when I take the inverse, and yes, I can take the inverse, it is no longer a function. It's like this. It's a u. It fails my vertical line test. It is no longer a function. So what I must do is restrict my domain, my x values. Where should I cut this? Where would you like me to cut this at so when I do the horizontal line test, it'll be successful? I want to get the most I possibly can. At 0, right? If I cut it right here and I choose either this half or this half, it passes my horizontal line test, correct? So let's do that. I'm going to restrict the domain. I'm going to say that x is going to be greater than or equal to 0. Did I choose the right side or the left side? The right side. So then with this here, I must restrict it. So when I go to graph it, I'm not going to graph that. I'm only going to graph, it says, go draw the parabola, but with only these x's. Go draw the parabola, but with only these x's. Okay, that's this piece. So when I'm supposed to go and sketch its inverse, well, I can do that. This is 0, 0 stays here. This is 1, 1 stays here. This is 2, 4 becomes 4, 2. And it is clearly a function. There's my f inverse, and here's my f. It's only a piece of my parabola. So let's go through these steps. Part A, And let's see. Let's pretend this is exactly what I gave you. The same part A, B, and C that I just did. 40 was a straight line. I didn't have to restrict its domain. 41, you will have to. It's some kind of a parabola. So let's see, what was part A? Part A says for me to find f inverse of x. All right, I'm going to go do it algebraically. It said, make that my y. That's step 1. Step 2 is switch them out. Step 3 is to isolate my y. Well, first off, I'm going to switch the order because that's going to bug me. How am I going to get to a y? I see a y squared there. How am I going to get to that? Oh, that's right. When I square root this, then it's the plus or minus of this, right? So y equals plus or minus the square root of x. Oh, wait, I'm sorry. Which kind of x values am I only allowed to use? The positive ones, right? Isn't that a way of just saying the positive ones? So then I only want the positive ones. Oh, hey, doesn't that look like the square root of x, parent function? 0, 0, over 1, up 1, over, oh, yeah, okay. Got it. And the restriction, we already know is still the same, right? The only thing I'm allowed to have is 0 and above. Got to bring down my restriction. And then what do? I go back and I write its name. I just did part A. I found f inverse. Part B. What was part B again? Oh, go graph them. Okay, so again, when you have to graph that, think of the parabola, but these are the x's you're allowed to sketch it out with. So they're going to be right or to the left, right? So you just have to be careful. And then, of course, do the cheating way, like I just did, switch out the ordered pairs to graph the f and f inverse, right? If you can do that one, switch the ordered pairs. Done. On pretty little graph paper, you're going to cut it out and put it on your line paper. Let's go to C. What was that again? Oh, yeah, the domain. The domain of f and the range of f, the domain of f inverse and the range of f inverse. Well, I'm just going to do this one. This is easy. It's my parabola. Let's see. What x's my domain am I allowed to use? I'm allowed to use from 0 to positive infinity. And then we know it's from 0 to positive infinity, right? My part of my parabola, right? Well, this one's just too easy again because they're identical, right? But normally this would go here, and this would go here. And now I'm done with that problem. So in your homework, it's not going to be as nice and simple as this. What they might have is this. What does that do to my parent function? Just vertically shift it up 2, right? 1, 2, it's up here. Oops, I'm supposed to do the right-hand side, right? That's all. So that means when you sketch it out, it's going to be over here. So most likely your f inverse still looks like the square root, but it's now been shifted to the right 2. So I bet you it's going to look something like that. Right? And so my x has to be greater than or equal to, let's see what it is. Has to be greater than or equal to 0. My x is greater than or equal, to 2. That is, I have to write the restriction. I have to write what domain I'm allowed to use. So this is going to be what your homework's going to be like. Some kind of vertical shift or horizontal shift. How am I going to get to that? I'm going to just go through the steps, right? Replace the y and the x, take the square root. You can do the algebra. Whatever you need help with, you just ask me tomorrow. Preferably ask each other first, like what you already did with 28. No one got it, so you ask me. The last piece that I just... remember I said I gave you practice pluses? Here's the practice plus homework. I went ahead and got it out of the textbook. Let's just practice for a moment. It's just another way of looking at it. Let's see. Input, and here's f of x. Here's input, and here's g of x. So this is one, whatever that picture is, and this is the g, right? 2, okay. So how am I going to answer this? Where should I start? G of 1, right? Is what we did last year. Go to g of 1. So you go to the g, that's over here, and I look at what x value? 1. And then it's like, on the g, put in a 1, and what is the y? That's what that asks. What is the y on the g function when x is 1? Oh, what is that? 1. So then you erase that, you put in a 1. Now you're asking, what is f of 1? Oh, f over here. So 1, so the answer is going to be 5. Okay. Doesn't this mean like this, but to switch out the g and f, right? That means g of f of negative 1. So that means I do that one first, and I put in negative 1 for x. I spit out a y. So now it's g of 1. So g of 1. This will take time. What do I do first? G of 10, right? I can do that. What is g of 10? Sweet. So now it says the inverse of f, put in negative 1. But I don't see the inverse of f. Yes, I do. Where's the inverse of f? I take which one? The f or the g? The f or the g? Oh, the f. And I do what to their order pairs to get the inverse? Oh, so in your head you're going to switch it. Create another one. There's that inverse right there. What is it? Inverse, right? The y's become the x's and the x's become the y's. So now this negative 1 over here on the x's is really what over here? Oh. Oh. Yes? No? Yes. Sweet. And then the last 6 here, instead of looking at a table, you're going to do it with the equations. So let's try one. There's nothing really all that straightforward. Let's just try this one. Look at that, it's a triple. What do you do first, though? H of 1. H, drop in 1 and get an answer. Erase H of 1, drop that in. Now you do F of that number. Go to F, drop in that number, get an answer, drop that in. Do G of that number, done. Yes? You can handle this. Okay, I'm done.